Alright, good morning everyone. Welcome to APNIC eLearning web class. Today is Wednesday again. It's 11 o'clock in the morning from Brisbane in Australia where I'm broadcasting this class. Today is the 8th of April in 2015 and as you know, every Wednesday is eLearning Wednesday. Today we have three sessions lined up and the first one is about best practices in managing internet resources. Before we go on to the details of this session, I'd like to first introduce myself just very briefly. My name is Cheryl Hermoso. I work as a training officer for APNIC. I am part of the training team. And as part of that team, we do conduct workshops, e-learnings, face-to-face trainings, and talks, seminars to different parts of the Asia Pacific region. That's where APNIC location is, of course. And the topics that we do cover are all internet technologies, IPv4, IPv6, DNS and DNSSEC, network security, BGP and routing, and internet resource management. Now, this session is part of the internet resource management curriculum, right? So we will be looking at different resources and how we can best manage them. Just a brief reminder that this class will run for 1 hour. Hopefully, we'll finish up everything by that time. And towards the end, I will ask you to fill in a survey. It's a very short survey just so we can gauge what happened in the class. And if you have any suggestions, you can also write it down there. I'll post the link to the survey as we are about to end the class. All right, now what are we going to cover for this session? As I've said, this is part of Internet Resource Management, so it's important for us to understand the different objectives and goals. These objectives are our way, or it helps us or reminds us um, how how best to look at resources and how to assign them. Okay, how are we going to use them? So we'll look at them. We'll look at IP addresses as part of the different resources. We'll look at IP and addressing plan, and how do we go about requesting for our IPv4 and IPv6 addresses? What's the difference between allocation and assignment? And how are we going to use this to assign to our network topologies? After that, we'll look at another resource called Autonomous System Number or AS number. And we'll look at different things about that that relates to how are we going to request that, how are we going to use it, and if we have customers that need that AS number, how are we going to go through about processing or requesting in behalf of them. The last one is about reverse DNS. As you know, APNIC also provides this feature to all APNIC members. Once you have a resource, a reverse DNS entry will be created for that particular IP block for you. And so how are we going to do that? Many people don't understand how reverse DNS works, more so how to manage reverse DNS. And so we'll try to clarify some of those things. And lastly, we will look at resource management tools. Basically, that is using MyAPNIC. And once you log into MyAPNIC, you have all the tools necessary for you to do all the tasks that you will learn here. All right, so that's the plan. Hopefully, you came here. That's what you're expecting to get. If you have more questions as we go on, please feel free to ask them. And also, if you have any suggestions or any comments, we want this class to be as interactive as possible. All right, let's begin with IRM objectives. So IRM is Internet Resource Management. And when we talk about internet resources, particularly we are referring to number resources, IPv4, IPv6, and autonomous system number. Now these are limited resources. We have enough of them. You can request that from APNIC or from the other RIRs if you're from another region. And you can get that, you can use that, but it's a limited resource. And so we want to look at these different objectives and make sure that it is fulfilled when we're doing a request. The first one is conservation. And conservation pretty much says that it's about an efficient use of resources. So when you come to request for a particular resource, it's only based on what you need. It's based on a demonstrated need, which means that you will have to be able to justify or show that you actually need an IP resource before you can get them. Now, when we talk about conservation, the best example that we can get perhaps is IPv4. With IPv4, as you probably know by this point, is at the point where it's exhausting. Okay, we are running out of IPv4 addresses. There's still enough to provide to new customers and those that are requesting, but at certain point in time in the future, it will run out. And so, because of this particular reason, we want to make it possible for everyone to still connect to the internet. Let's keep the internet growing. And so you should be able to only get an IP block that is enough for your needs for the next couple of years. Nothing more than that. There's no such thing as a reservation policy. You cannot just request for an IP address because you want to. You should be able to demonstrate that you need them and will use them for your infrastructure in the next couple of years. The next one is aggregation. Aggregation is about limiting the growth of the routing table. Through this, what we need to do is be able to combine or join smaller IP blocks into a single block and announce them as a single prefix to the global routing table. Now, for this purpose, I think the best example that we can look at is IPv6. IPv6 is a bigger pool, okay? The IPv6 address space is a bigger pool than the IPv4 address space. So when you look at the current IPv4 routing table, it's already got about 400, I think 40 to 50,000, right? But when you talk about IPv6, it's not at that point yet, but there is a tendency for IPv6 to grow very big, to grow very large. Okay, if you are allowed to announce, okay, yeah, the resolution, yeah, I noticed that. Thanks for that. I'll just try to explain them. Sorry about that. I'm not sure why it didn't turn out right or correct when I uploaded them. You can also have a copy of the slides after this. They should have a better, yeah, it should have a better quality graphics than this one. I think it has to do with uploading to Adobe Connect. But yeah, thanks for that. As I was saying, with aggregation in IPv6, there's a tendency for IPv6 addresses to easily fill up the routing table. And so when you are going to request or manage your IPv6 space, please take note of aggregation as an objective. All right. The last one among those objectives, the last of the three that we usually want to emphasize is registration. And with registration, it has to do with once you have your IP address block or any other resource for that matter, you should you should register that and keep that registration updated at all times. Why is that necessary? For two reasons. One is it ensures uniqueness. As you know, with IP resources, you have to be unique. Okay, two hosts cannot have the same IP address. Okay, two networks cannot announce the same IP address prefix. Otherwise, there will be some chaos with routing. So we want to register that for that purpose. The other one is it facilitates troubleshooting. The internet is a community-based infrastructure. If there's a problem, some IP address prefix is used for spamming or any abuse for that matter, you should be able to use the database to look for help or to seek who is in charge of that IP address block. So those three things I just want to emphasize again are conservation, aggregation, and registration. Now there are others such as uniqueness, fairness, and consistency. You can find that in the policy documents that you can see in apnic.net/policy. All right, but our focus is only in the first three ones. All right, let's look at the first resource, which is IP address. So I've already mentioned one problem or one issue that we are facing with IP address, and that is the exhaustion of IPv4 addresses. Right now, we are in the final /8 in the we're using the final /8 block in our region, and we've started distributing from that block in 2011. Okay, so I think usage-wise, we are at around 80%. And what happens? What is the implication of this exhaustion? Right now, if you need IP address, the maximum that you can request, aside from the basis of demonstrated need, the maximum that you can request is a slash 22, and that is coming from that final slash 8 block. All right. So that means that there is a limit that you can request. Is that enough for a new, say, new service provider? Probably not. The only reason we're giving that is because it allows the network or the internet to still grow. It allows you or your network to then transition into using IPv6. Now, this problem is not exactly a very new one. They've discovered that issue. They know about that issue earlier on in the 1990s. But it's only now that we are really becoming more aware of this because of the restrictions and the distribution in the final slash 8. The next issue is the continuous growth in the size of the routing table. And through this, we have already looked at aggregation as a possible solution to this, right? The size of the routing table is due to the higher number of prefix announcements. What does that mean? If you are an LIR, a local internet registry, or sometimes we call it as an ISP, a service provider, you have customers. Now, if these customers are using their own IP address blocks that we call as portable IP address, then you will have to announce these blocks. Most likely, these are requested separately, and so they are not aggregatable address. And so if you have 100 customers, you end up announcing 100 extra prefixes onto the routing table. Now consider you're using aggregation. You are an LIR. You're now giving or providing your customers with a provider aggregatable address space, meaning it's a non-portable address. So you have a block. Let's say you have a slash 20 block, and you give smaller blocks to your customers. Let's say slash 24 or slash 27 blocks. Now, because this is from a non-portable address that is coming from a bigger prefix, you can easily combine them together and announce them as a single prefix onto the global routing table. That somehow addresses this issue of the routing table growth. All right, so that has been a big issue at the very start because of the limitations that we have on our routers. The last one, although I'm not exactly sure if we can consider this as an issue or a problem, is the tremendous growth of the internet. We should be happy that the internet is growing. Okay, it's still growing as of this point. The problem mainly is that we don't have the IP addresses to support that growth, and as a result, we're also having some routing chaos or increase in the routing table size. Now, how do we address these issues? As I've said, most of these issues we already know. We all have already identified earlier on in the 1990s. So there are ways, there have been discussions on how it can be addressed. With the size of the routing table as well as with the exhaustion of IPv4, one main way to address that is to use classless addressing over classful address. Now, this only means that for your sake, for example, if you are going to distribute smaller IP blocks to your customers, then you don't have to stick with the classful boundaries, okay, if they need only a smaller block. So with classful addressing, we have three types. We have class A, class B, and class C. Nowadays, we don't worry about those boundaries anymore. We have the freedom to go through each bit. Okay, so you can have, if you need something that is only 100, maybe you only need 100 IP address, you don't necessarily have to get a slash 24, which gives you 255 addresses, right? If you need, let's say, 500 IP addresses, you don't just get a class B, okay, which is equivalent to about 65,000 IP addresses when you only need, let's say, 500, right? Because classful address addressing tends to become more wasteful. Okay, classless addresses is a more efficient way to distribute IP address. So coming from Ayala to the RIRs, including APNIC, we use this. Coming from you, going to your customers, you should also use classless addressing to announce for your, maybe just for your specific parts of your infrastructure, or maybe to assign to your customers, right? Part of that classless addressing is also CIDR, the classless inter-domain routing. Now, because we are using classless addresses, we need to also provide the prefix, okay, into the routing table, so we know how to route these prefixes, or how to route these packets. So that's CIDR. With CIDR, it also allows aggregation of your IP prefixes, right? So again, it solves the issue of the growth in the routing table size. So these are best practices. If you can, also please do this. Please do not use classful addressing anymore because it's already obsolete. Now, I'd like to just show you very quickly the growth of the routing table. Now, as I've mentioned in the past two slides, we said that the internet is growing and the routing table is really, say, congested. Well, right now, as of yesterday, when I created and updated this slide, we have about 546,000 prefixes in the global routing table. Okay, that's as of 6th of April, yesterday. And if you look at this slide, it actually goes through the very beginning, which is the late 1980s, when the internet started really growing and becoming more mainstream. So in 94, that's the time that we introduced CIDR. If we did not do that, we would have run out of IP addresses sooner, because the projected growth of the routing table would have been like this. Because of the introduction of CIDR, it became more linear, and basically it's more manageable growth in this way. And around 2000 and 2001 is a dot-com boom, so many people want to connect to the internet, want their presence on the internet, and so again it grew a little bit. In 2001, that's a great internet boom and bust. In 2005, we have broadband became more available to the masses, so you can see the growth here. It's not exactly exponential in a big way, but you see a very good growth. But this growth is still sustainable up to right now, where we have reached, okay, the address exhaustion. So you can see that we did not exactly just run out of IP address here. It is still growing, and we want to make it that way. We want the internet to still keep on growing. Now consider IPv6. This is the global routing table for IPv6. Now it's not as big as IPv4 per se, because in IPv4, we have about 500,000. With IPv6, we only have about 22,500 prefixes as of yesterday. No, I think as of last week when I created this. Now, the good thing here is when we started in the late 90s or early 2000, this is growth. It's not very big, it's not peaking up. But around 2008, 2009, up to now, you see major, very big growth in the size of the global routing table, which is a good thing, because meaning more networks are starting to deploy IPv6. They are announcing their IPv6 prefixes. Some of them, hopefully most of them, are now reachable via IPv6. All right, so that's a good thing if you are planning to also implement IPv6 sooner, which I, by the way, will recommend. It's a good time to do it because it's already growing. All right, now specifically with resource management, with IPv4 and IPv6, when you come to request from the RIR, you get either an allocation or assignment. An allocation is when you get it for further delegation to your customers. If you're an ISP or an LIR, then you will get an allocation for further delegation to your customers. If you are going to use that for your own infrastructure, we call that as assignment. So there are two ways to get your IP address. You can either get that directly from an RIR, such as APNIC, or you can get that from your upstream provider. So if it's coming from APNIC, you notice that this is the block. From APNIC, we have a /12 IPv6 block. That can be either an assignment or an allocation. Again, depending whether the requesting member need that for their own infrastructure or for further delegation. So you have to be very clear on that when you're doing your request. Do you want an allocation? Do you want an assignment? Now, if it is an allocation, as I've said, it is for further delegation. So your customers, okay, or your the networks that are subscribed to you can get their IP address by two means as well. It can be either a sub-allocation or an assignment. Assignment if they're end users, sub-allocation if they are perhaps a smaller provider that will then have to distribute IP address to their customers. So that's how it likes. That's kind of the hierarchy of providing IP address. We have a big block assigned to APNIC. APNIC assigns a /32 or /48 block to its customers, depending on what type, and then customers can now distribute smaller blocks to their customers. All right. Now, I've already discussed a little bit about portable and non-portable. So basically, with portable address, that's a provider-independent address. Okay, that is assigned by the RIR to end users. If you go back to the previous slide, this one from APNIC block of /12, we can assign a portable address, okay, to this customer. Okay, anything that's coming from the RIR is portable address or provider independent address, or sometimes you also call it as a PI address, right? Anything that's coming from your upstream providers, if you notice this one, is non-portable, right? So that's the difference between them. Now, the good thing about having a portable address is if you have to change a provider, if you're not happy with your current provider, if you want to switch to another one, you get to keep using the IP block that has been assigned to you. Because again, you did not request them from your upstream provider. Okay, the downside to that is the increase in the routing table size. I've already mentioned that earlier. We said that if you have 100 customers, in this case we only have 4, you end up announcing each of those portable addresses upstream, okay, because they are not aggregatable. So that's a portable address, okay. Again, there's positive and negative sides into it. Positive side is you can use an IP address. You don't have to renumber if you're changing to a different upstream provider. But the downside is it adds to the size of the routing table if you will ask your upstream provider to announce that block for you. Now, the non-portable address is sometimes also called a provider aggregatable or PA space. With this one, the IP address block is assigned by the ISP. So if you're the LIR, you're the ISP, you come to APNIC and request for a block. Let's just say for IPv6, you requested for a /32 IPv6 block. Now from that /32, you will give your customers, you will delegate smaller blocks to them. Maybe you're assigning /56 or /48 blocks going to your customers. Since this is coming from a big block, then you can aggregate these blocks and announce as a single IP block. Okay. Downside is if you're the customers, you have to renumber if you're changing an upstream provider. But the good thing is, again, it is an aggregatable space. So hopefully it's clear between portable and non-portable. If you have some issues or if you have some confusion about that, just please always refer to this diagram. It's kind of a clear way of remembering, okay, which blocks are portable, which ones are not, which ones are allocation, and which ones are assignment. All right, so I hope that's clear enough. Now, part of resource management is not just knowing the criteria when you're requesting space. Once you already have the IP space, you should be able to still think of or apply the different objectives, okay, when one, you are assigning them to your network, to your infrastructure, or when you're assigning them or delegating them to your customers. That's where addressing plan comes in. Also, when you're just requesting, you also need the address plan because that makes for your justification for your demonstrated need, right? So with addressing plan, okay, it's just good practice, main practice if you're the network designer to be able to identify the different components of your networks. How many customers do you have? How many customers will you have in 5 years? So you must know that projection. How about your infrastructure? How many, say, POPs do you currently have? Are you planning to expand in the next 2 years or in the next 5 years? For each particular POP or parts of your network, is it growing bigger than the other region or the other parts of your network? If so, what are you planning to do it? Are you going to deploy more, say, more routers, more switches, more infrastructure in that area? Things like that should be planned accordingly. You should be able to identify which parts of your networks needs update in the coming years. Why is that important from a resource management point of view? Because you will have to create a proper address plan. Okay, how do you assign the block that you currently have? What is the best way to assign it so that it's not wasteful? Okay, I don't end up just and let's say giving a big block onto a network that will not grow in the next few years, right? Or in the other um, side, you don't end up giving too little, okay, on the part of your network that has a tendency to grow big in the next few years, okay? Because if that happens, you might end up renumbering. And addressing plan is a very daunting task, okay? So that's the first step. Identify the components. Identify the phases of deployment is the second one. Okay, so if you're just designing from scratch, then it's actually sometimes easier to do that rather than updating or upgrading from existing ones. So you should be able to identify at which phase of deployment or development you are in. Are you just starting off? Are you 6 months away? In the next year, how do you think this network will grow? Okay, and from that, identify what equipment will be added later on, what changes are expected to happen depending on your plan. Do you need any form of redundancy, which means you will have to add more, say, you'll have to assign more IP blocks for that particular part of your network? Is there a need to scale your network? And if you're going to do that, is it easy to scale? All right. So those are really important things or pointers that you need to understand before you do your addressing plan. If you are planning to create redundancies or make that network bigger in this year, do you have enough IP, okay, reserved for that purpose, right? Or assigned for that purpose, all right? So those things you have to be able to understand. Now, not just from the technical perspective, but from um, the way that you deal with or request for your blocks. Within APNIC, you already know or you're already aware that all address space are based on demonstrated need. And so when you request or when you assign smaller blocks, it has to be well documented. Okay? Um, it is also good to check with other NARs or RARs or NAR databases for different allocations. So if you have IP blocks that were obtained from that process when you're going to request from APNIC, you also need to show that. Okay, you also need to inform us that you have these blocks but not taken exactly or requested exactly just from APNIC. You got that from other sources. That's especially true for multinational companies, right? Next is no reservations policy, right? I've already mentioned that, and we said that because we don't have enough, you need to be able to provide that you actually need that. And that only means to show that you cannot reserve any IP block, okay? There's no such thing as reservation. Hey, I'm gonna need this block in 5 years' time. Maybe you should request now. a just way to do, right? So there's no reservation. You should be able to present your plan, addressing plan that I have mentioned in the previous slide, when you are going to request for your resources. Now, what about sub-allocations? The thing is, when you come to request from APNIC, or maybe sometimes from your National Internet Registry or NIR, it's sometimes easy because the people you deal with, let's say APNIC personnel, APNIC hostmasters, are particularly aware with these resource management objectives. But going downstream, once you already have your blocks and you are sub-allocating or delegating to your customers, then sometimes if you are the person tasked or assigned to do it, it can be daunting, okay, especially if you're just starting to do that. So with sub-allocation, are there any rules or best practices? Actually, assigning to your customers, the size that you're going to assign depends on you. There is no particular line in the policy document that tells you what is the biggest size that you can assign. Okay, so there's no max or minimum size. However, think of the objectives. Again, if it's IPv4 you want to conserve, okay? So you don't just give out big blocks to your customers just because they have the money to pay for it, right? I give it because they also need that block, right? Another thing is you don't have enough blocks for yourself anyway. So when you do your delegation, make sure that you properly um, subdivide them, okay, to all your customers. So typical way is when you get a /22 block from APNIC. So that's the biggest size that you can get, right? From the final /8. By the way, I just would like to mention as well that there is another block, another /22 block where you can request, okay? So basically, you can request a /22 from the final /8 block. You can request another /22 from a block of return pool. Just be aware that these two are from different blocks and so they are not aggregatable themselves, but you can request them. That's a good news. For most of us who have already used up the /22 block, have already requested that, now you can actually request for more, right? So from that block, this example is from the /22 final /8 block. You sub-allocate /24s perhaps to a downstream ISP, and from there they will assign smaller /27/26 blocks to customers. If it's home users, broadband users, what I notice is they also assign either a /30 or sometimes even a /32 IPv4 block, right? So, but there is no particular um, practice or rule in the policy document that limits you on how to assign them. Okay. The thing is, you must be able to get reasons or justifications as well from your customers that they will be able to use that in the next year or so. Again, that is same objectives that we use when we're assigning it from the RIR going to you. Now, there's such a thing as assignment window and second opinion request. What is this? When you are new to APNIC, you are usually assigned a very small assignment window. An assignment window is the block, the size of the block that you can assign downstream to your customers, okay, when you don't exactly need a second opinion yet. So basically, if you have an assignment window of /26, if a customer comes to you and requests for a /26, you can assign that /26 to them. If you have another customer, customer B, coming to you and they need a bigger block, maybe they need a /25. Now your assignment window is /26. It's smaller than what they are requesting. In that scenario, you cannot exactly just assign that /25 right away. You must come to APNIC and request for a second opinion. A second opinion request is APNIC's way of assisting members by making decisions that relates to these resource management, these types of delegations. So that's assignment window. As you grow bigger, as you become more familiar in these processes, your assignment window usually becomes bigger. And every year during your anniversary of your membership, you that assignment window is also reviewed and sometimes increased. All right. So those two things are important when you're doing sub-allocation. With IPv6, on the other hand, there is no particular requirement that asks you to do a second opinion request. However, the only thing that you can see in the documents, policy documents right now, is that for all /48 assignments going to your end user customers, they must be registered. Okay, let's assume that you have a /32 allocation coming from APNIC. Now, from that /32, you are assigning them to your different types of customers. One type of customer will be some smaller ISP perhaps, so you end up assigning them with a /40. Now, you have end user customers where some of them will request /64, /56, and /48. Now, there is no particular rule that tells you you can only assign this much black to your customers. No, it is based on your own policies, based on your own company policies. Most likely, okay, based on practices that we've seen on the internet community, typically they assign one of these blocks, 64, 56, or 48. Okay, now if you are assigning anything from /48, okay, and bigger, it is well recommended that you make that assignment reflected in your APNIC who is database. All right. So if it's greater than that, that's a time that you get or seek a second opinion request from APNIC. That's because typically, even coming from APNIC itself, when someone requests for a portable assignment, they get a /48. Okay, it's very unlikely to request for something bigger than that. So same goes to your customers. Anything that's more than 48, it is best that you seek for a second opinion from APNIC. Now, some sub-allocation guidelines here, I really like to emphasize this because, as I've said earlier, the IRM objectives are not just implemented when you're requesting resource from APNIC. It is also implemented when you're doing sub-allocations going to your downstreams. And in this case, it will be up to you to make those decisions, okay? So for sub-allocations, make sure that you sub-allocate cautiously. If you're in doubt, if you're new to this, come to APNIC. We have APNIC Hostmasters. We have APNIC Help Desk that can help you with that. If the customers are requesting very big blocks that can meet the portable allocation, it is also best to refer them to request for a portable address directly to APNIC instead. Make sure that your assignments are done in an efficient way, okay? Your LIR, your network, is responsible for the overall utilization of the blocks that you are currently holding. And lastly, you remember the goal of registration. Make sure that it is registered and that is done using the WHOIS database. All sub-allocations and assignments are optional if you want to put them onto the database, but if you can, then please also do so. Now, with assignments, the first few ones are mostly with allocation. With address assignments, again, it should be based on the demonstrated need. For your customers, make sure that they are able to provide you detailed documentation that they need these particular addresses. And that is because we don't want to just waste IP address, right? We want to minimize wastage. We've talked about classless addresses earlier on. Make sure that you utilize them. Make sure to use classless assignments when you're assigning IP address blocks. In terms of current policies, these are the block sizes that you can get. The maximum block that you can request is normally a /48 coming from APNIC, and the minimum is a /64. Just please be aware that /64s are usually just used for a single subnet, meaning that it's only for even if you have, say, 100 machines on the same network or just one or two, it's the same thing. You assign a /64 for that subnet. So if you're expected to grow or you have more subnets in the future, then you have to take that into consideration if you're doing your assignment to your customers, right? Next is if you want to assign multiple /48s to a single end site, you can request for that. But right now, if your customer requests for that, please refer them to the RIR or to the NIR, because so far we have not received any requests like that. So normally it will be reviewed at the RIR level until we have more experiences about that. Last one is if you're an operator and if you have an infrastructure, you are eligible to get a /48 assignment for each of your POPs, regardless of the size of your POP. All right, so that's mostly the resource management best practices that we do for IP addresses, right? That's the bulk of our discussion. Now, I'll just take a few more slides, a few more minutes to discuss about the other types of resources, which is AS number, and related to IP address, we have reverse DNS. For AS number, what exactly is an AS? An AS is autonomous system, so each network that is defined by a single proprietorship, single owner, single policy in their network normally belongs to one AS, and an autonomous system is identified with a unique number called ASN. So that's how you do peering with different networks on the internet. You use the AS number. It's very important in BGP. That's your global unique identifier. So who can come to APNIC to request for an ASN? Of course, you, any member, any APNIC member can come to APNIC and request for that AS number. Well, this one's a more definition of both AS and ASN, so you already know that. Now, when you are in need of an ASN, normally that's because you are multi-homing. Okay, multi-homing is when for your network you have at least 2 upstream providers and you want to announce your IP address prefix to both of these upstreams. So if you're doing multi-homing and your routing policy is different from your neighbors, from your peers, or from your upstream or transit providers, then you'll probably need an ASN. If you're not sure yet, or you're confused what exactly is an ASN, or where and when you can use it, please refer to RC 1930 for some guidelines. Now, when you're requesting for an ASN, as I've already said earlier, you should be multi-homed and you should have a single, clearly defined policy different from your upstream's routing policies. So those are the eligibility rules. That only means to show that you have your own multi-homing network, right? We've already discussed in the previous slide. Now, how do you go about the request process? Now, 2 things that you need here is, of course, you have to be able to identify your peers that you will be peering with. Okay, this is BGP. If you're not sure how that works, please attend another session about AS numbers where we discuss this in more detail. Now, if you're the one assigned by your company, your organization, to deal with APNIC to request for this AS number, this can easily be done through My APNIC. So if you need to have an account, log into My APNIC, go to the Resources tab, and from there, you can see the form to request for an AS number. When you request, we don't really differentiate between 2-byte and 4-byte AS numbers anymore. By default, you will get a 4-byte AS number. Now, if your infrastructure, if your routers cannot support that, make sure to specifically mention that you need a 2-byte AS numbers. Okay, so that's how you do it. You need to be able to show or provide details about at least two peering partners. Okay, two peers and their information about them, the AS number and everything. You can see that in the form as well. If you're a new member, you're not an APNIC member, then you can request for your membership and request for the AS number all at the same time. You can also actually request for an AS number for your customers. Okay, let me just have a look. If I don't have the slide there, but you can request for an AS number to going to your customers. Basically, similar to IP address, there is portable and non-portable ASN. So same definition. If it's a portable AS number, it means that it came from the RIR, and you as a member can use it even though you are using different upstream providers, but you're basically in charge or responsible for the registration. If it's a non-portable AS number, you request that coming from your upstream. Okay, if you're the APNIC member, you get the portable address. But if you have downstream customers, okay, and they need an AS number, they can actually request for an AS number through you. Okay, so you don't have a pool of AS numbers that you can give to your customers. But when your customer needs an AS number, they can come to you, and you will come to APNIC and do the request process in behalf of your customer. In that case, that type of AS number is non-portable because there is an agreement between you and your customer. If they cease to use your services, then they will have to let go of the current AS number that they have through you and then request for another one coming from their new upstream provider. All right, so that's portable ASN and non-portable ASN. This is through non-portable ASN. This is how you can request for an AS number for your customers, okay, if you are the APNIC member. Any questions on AS number? So just a very brief overview on that. So same with IP resources. You come to APNIC for your AS request if you are in need of that, right? Or if your customer needs AS numbers. Now for the last point, we have reverse DNS. Every IP address block that you requested from APNIC, whether it's IPv4 and IPv6, APNIC automatically manages and creates a reverse delegation for that IP address block. Okay, now this is particularly important for zone or DNS administrators. They must have entries for reverse DNS, right? And this block has been delegated to you as an APNIC member. Now, before you register your domain objects, please make sure that your reverse zones have been configured and loaded in your DNS name servers. So basically, let's just say, for example, that you have an IPv4 block for 202.106.100/24. So I'm just making that up. So you probably have that /24 block. So I said APNIC automatically delegates that to you, right? Let's just say that you have a /20 block, and then delegation for that is actually done per /24. So you should have 2⁴, so which is 16 /24 delegations for you. So for each of that /24, okay, you will have to provide your DNS name servers. Okay, so maybe it's the same for all of them, or maybe it's different for each /24, but please provide the fully qualified domain name or FQDN of your DNS name servers. Make sure that it is already properly configured and loaded before you do so, right? APNIC only delegates the authority of your reverse zones to the DNS servers that you provide through your domain objects. Right? So in the domain object, in the APNIC OS database, look for your IP address block and see that for the domain object for that IP address block, see that the name servers are correct. If it's not, please log into your MyAPNIC account and then edit that OS object. If you don't have those entries and you want to delegate that to particular DNS servers, you can also do that using the MyAPNIC portal. So I think by now you know that I've been mentioning it from the very start, that the best way to manage your resources, okay, coming from APNIC is through MyAPNIC. So MyAPNIC is a web services portal. It's a secure portal for APNIC members to manage their internet resources as well as other things. It has your membership details, account information, all that. Particularly for this session, we want to be able to manage our resources, and you do that through the resources tab in MyAPNIC, right? You can manage your IP addresses, your AS numbers, your reverse delegation. If you are implementing DNSSEC, you can also update your domain object so that you can upload the DS record, so you have that full delegation for you. You can also update other things like such as your membership, your contacts, payments, etc. That is through myapnic.net. So if you don't have an account in MyAPNIC yet, please register. For each organization, they will have one corporate contact. If you are the corporate contact, you can register and you'll have access straight away after verifying the confirmation link. If you are not the corporate contact, the corporate contact needs to approve your registration before you can have access to MyAPNIC. So you might need to nudge them and tell them to approve your registration. So that's MyAPNIC. If you can, please log into that and try to look at your current resources. If you need to do sub-allocation, sub-delegation, you can pretty much do it through that. Okay? That's pretty much it. That's what I want to cover for this session. If you have any questions, now is the time to do so. Please write your questions as usual in the chat panel on the lower right hand side of your screens. Alright, I don't think there is anyone typing, so I'm going to write the link to the survey here. Assuming that you all are okay with the discussion, you don't have any particular questions related to that, this is the link to the survey. Please fill it in for me. I'd be very happy if you do that. Now, if you want a copy of the slides, you can download that from this link. I'll just quickly type that in onto the chat. That's the link to the FTP page where you can download a PDF copy of all the materials that we are using for today. If there are no more questions, I'm going to end this session now. If you think of anything later on, please feel free to send us an email at training@apnic.net. All right, thank you very much, everyone, and I'm so happy that you were able to join us. Please join us again in the next session at 1 o'clock in the afternoon. And the topic is IPv6 addressing, if that's something interesting to you. All right, thanks again, and I hope to see you in another e-learning session. Bye-bye.